So welcome. This is a mock-up of a open screw pump. Screw pumps can be enclosed in a cylindrical tube, but the open type is the most efficient, and they are among the most efficient types of pumps where the volume is right, upwards of above a third of a cubic meter per second or something like that. So you can see that I just made the one vane, got the spiral, the screw pump assembly with no drive at the top. This is where the discussion begins, because these days, generally, some sort of AC motor will be in here, turning a relatively close ratio gear train and putting this energy in at the center of rotation, which is just the totally wrong place to put it in. This sort of approach is inherently flawed, and it can never reach its true potential in terms of efficiency. Contrary-wise, instead of putting the energy in at the center of rotation, where it's stupid, a largish ring gear, spur, whatever type were used with a similar but correctly spec'd AC prime mover, efficiency would be instantly increased by 50%, I'm guessing. So this leads us to one of my favorite topics. Well, pumped hydropower. Not to be confused with pumped storage, because there's almost no storage involved in this concept. You have a pump on one side raising water, X meters. At the top, that water gets put into a turbine of whatever type, and it goes back down and it makes power. So you have an enclosed loop of this water going up and down. So, this is a freestanding system. So, the debate proceeds to this. Can more potential watts be produced by this new improved drive mechanism in raised water, potential power energy in raised water in excess of what was consumed to make the pump go around? This would be an overunity configuration if it flies, and it certainly should be researched more. While things are not necessarily to scale here, they're not too far off. If we assume the screw has a radius of half a meter or so, that makes this gear just ridiculously large in most of the worlds and most applications, unless you want maximum performance, maximum efficiency upwards of up to the point where you can raise enough water to make a profit in terms of energy. So, but again, you don't need a river or a stream. You just need to be able to contain this water and replenish it. There's a possibility that substances other than water could be used. Maybe supersaturated water, or even lead spheres, or plutonium spheres, to just get maximum density in there. It would be noisy, you know, one would have to consider that factor, but anyway, so now you know, it's just one more place where modern world has just said, oh, we don't need a full-size lever, we don't need a full-size rotary second-class lever. We can do fine with these little bitty gears where we've just thrown all this power away. So, a big gear like this, a meter-sized gear like this is problematic, but it's solvable problems. Modern metallurgy could come up with materials that could make this fly, you know, in 20 minutes. Same way with the gear design. A very simple idea is that where a gear mesh, where the components of a gear mesh are of slightly different hardnesses, there's a pseudo self-lubrication effect that happens, and the mesh is minimized as a result, without spraying grease in there or what have you. It's a dry mesh. Well, I don't know, I'm guessing about that, but it would seem to be mostly a dry mesh. On the other hand, I'm not saying that it shouldn't be a lubricated gear mesh. I'm just saying we should be putting power in out here where there's a semblance of mechanical advantage over the load. The end. Thanks.